The universe is currently in motion, with every galaxy we can see drifting away from every other galaxy. Observations show that this movement is actually picking up speed. The further a galaxy gets from us, the faster it travels. This creates a physical tug-of-war between the outward push of expansion and the inward pull of gravity, trying to keep stars and galaxies together. If this acceleration continues to increase, it will eventually overcome the gravitational bonds that maintain every structure in the cosmos. The ultimate fate of our universe depends on the mathematical outcome of this fight, and which force eventually wins. If expansion wins and completely overpowers gravity, we face a scenario called the Big Rip. In this version of the future, the expansion of space happens so quickly that gravity loses its ability to hold anything together. First, galaxy clusters are pulled apart, followed by the destruction of planets and stars as the space they occupy stretches too far to support them. This stretching eventually reaches the microscopic level, where even individual atoms are torn to pieces. There is an opposite possibility where gravity wins the tug-of-war, leading to the Big Crunch. This theory suggests that the universe has a maximum size limit it cannot expand past. Once the universe reaches that edge, the outward momentum stops and reverses, with gravity collapsing everything back into a single, incredibly dense point. Both of these outcomes represent a violent end to reality, either through the total shredding of matter or a claustrophobic collapse. A third possibility exists where the two forces reach a permanent stalemate, known as the Big Freeze. In this scenario, the universe continues to grow, but the acceleration eventually stops. Matter continues to drift apart, spreading out thinner and thinner across an ever-widening void. Because the same amount of energy is being distributed over more and more space, the entire universe begins to cool down. Eventually, the cosmos reaches a temperature where it can no longer support the light of stars or the chemistry of biological life. The Big Freeze results in a universe defined by absolute stillness and infinite isolation. These scenarios won't happen for billions of years, giving us plenty of time to study the mechanics behind them. Scientists are currently trying to determine which fate is most likely, but the answer depends on one specific value. We need to know the exact amount of energy that exists within empty space. To find it, astrophysicists are currently examining a brand new dataset that provides the most detailed look at this energy to date. By measuring what is happening inside the vacuum of space, we can finally calculate how the universe will eventually reach its conclusion.